Welcome to qnawire.
In this question, there are two links, A, B, and CE, and then they are pinned at, not say pinned at D, but they intersect at D. Okay, and at this instance, block A is moving downward at 4 meters per second. We need to determine the velocities of blocks B and C at the instance shown. Okay, so now we collect some of the known information. So VA is minus 4j meters per second. Here again, this is our coordinate system. And then we first find VB. VB is equal to VA plus omega AB cross RB relative to A. Okay, so VA and VB based on this diagram, when VA is moving downward, VB is going to move to the right. Okay, so VB I hat is equal to minus 4j plus, so take the fact that A is moving downward and B is going to move right, that leads to AB going clockwise. Okay, so this will be minus omega AB K cross, then our position of B relative to A, this is equal to 0.55 minus cosine theta I plus sine theta J. Okay, so so this is our theta, and then we have a 3, 4, 5 triangle here. So this is 3, this is 4, this is 5. Okay, so sine theta is 3/5, and then cosine theta is 4/5. Okay, so now we continue. So this is minus 4j plus 0.55 omega AB. Okay, so k cross minus minus I, we get j, and cosine theta is 4/5 j, and then minus k cross j is plus I, so we have 3/5 I. Okay, so this is equal to VBI is equal to 0.33 omega AB I plus 0.44 omega AB minus 4j. Okay, so we compare components. So omega AB is equal to 4 divided by 0.44. So this is 9.09 radians per second. And then we have VB is equal to 0.33 omega AB, and then this is equal to 3 meters per second. Okay, so our first answer for VB is 3 meters per second to the right. Okay, next we want to find VC. Okay, we want to find VC. So to find VC, so C is going to move because of the rotation of CE. Okay, the link CE. So we need to find omega CE as well as VD. Okay, so first we find VD. is equal to VA plus omega AB cross R D relative to A. So this is equal to minus 4J plus minus 9.09 K cross 0.3 minus cosine theta I plus sine theta J. Okay, so this is equal to minus 4J plus, so we call that cosine theta, this is 4/5, and then sine theta is 3/5. Okay, then when you substitute, you do the cross product, you get 1.64I plus 2.18J. Okay, then this is, so VD will be 1.64I minus 1.82J. Next, we find VC. Okay, VC will be equal to VD plus omega CD cross RC relative to D. Okay, so this is equal to, so based on the diagram, again, VC is going to move to the right. Okay, so VC I is equal to VD is 1.64I minus 1.82J plus omega CD K, assuming this is counterclockwise, cross, and then so the position of C relative to D will be related to the 400 mm and the angle 30 degrees. Okay, so this is 0.4 minus cosine 30 degrees I minus sine 30 degrees J. So this is equal to, continue, 1.64I minus 1.82J plus 0.2 omega CD. Okay, so recall that cosine 30 degrees is root 3/2, sine 30 degrees is half. Okay, so the half multiplied with the 0.4 gives 0.2, and omega CD is come from the omega CD vector, and then do the cross product. So K cross minus I gives minus root 3J, okay, and then K cross minus J gives I. Okay, and then grouping the components, so you have 1.64 plus 0.2 omega CD I minus 1.82 minus 0.2 root 3 omega CD J. Okay, then we compare components again. So we start from the Y component because we can get omega CD right away. So from the Y components, we have omega CD is equal to 1.82 divided by 0.2 root 3. Okay, so calculate, you get minus 5.25 radians per second. Okay, then we can find our VC. So by looking at the X component, VC would be 1.64 plus 0.2 omega CD, and then you substitute omega CD from the previous statements, you get VC to be 0.587 meters per second. Okay, so this is the answer for VC. And that's all for this question.